For this integral, we're going to have a quadratic sort of denominator, although it's not necessarily quadratic. So we have integral 2 over x cubed plus 2x squared dx. We're going to factor an x squared out. And so just worrying about the rational expression, if we factor an x squared out, that's going to leave us with x plus 2. Now, this is a case where we have a repeated linear factor. And we haven't seen that before, okay, in the examples. So to be able to go through and simplify this, or to be able to break it apart into the partial fractions, we're going to need an a over x, so for the first power, and then a b over x squared for the second power. And then we're also going to need c over x plus 2, right? Now we're going to clear this out. And we're going to have that 2 is equal to a. We get rid of one of the x's. And we still have the x plus 2. We get rid of both of the x's, and we're left with x plus 2. And then for c, we have both of the powers of 2 there, right? Now, let's go ahead and use the system method, all right? It doesn't matter which one we use. We could pick 0, we could pick -2, but that means that we would still have one more variable to solve for. And so I'm going to rewrite this as 0x squared plus 0x plus 2, because we have to have some powers of x squared. Distributing, we have ax squared plus 2a, bx plus 2b, and then cx squared. So we have two x squared terms, and they have to be equal to the x squared on the left-hand side. And so in our system, a plus c is going to be equal to 0. Okay, and then what I usually do is I just cross them off because I'm done with them. We only have one power. Oh, this should be ax. Excuse me. All right, I didn't realize that. I forgot to distribute that through. So right here, this should be 2ax. Right. So we have two powers of x. So we have 2ax and bx. That has to be equal to 0. So that means that 2a plus b is going to be equal to 0. And then nicely, we just have this 2b, which is going to be equal to 2. And so our system is really nice this time. It yields that b is going to be equal to 1. And then over here, we can say that 2a plus 1 is going to be 0. That means that a is going to be a -1/2. And since a plus c is going to be equal to 0, that means that -1/2 plus c equals 0, or c equals 1/2. All right. And now what we can do is we can go ahead, just stick everything back in here, and then integrate term by term. And we're going to get a little bit different sort of answer than what we've gotten in the last few examples with these integrals. Okay. So now we're going to have the integral of -1/2 over x dx. Okay. And remember, what we're doing is we're just substituting back in right here for a, b, and c, and then just throwing the integral sign in front of those. We have 1 over x squared dx. And then finally, we have a +1/2 over x plus 2. All right, from the factor that we got all the way back up here, dx. All right. Now we're going to integrate term by term, at least for these two. Okay, these two are ready, but this guy, a lot of students will do this, okay, or a lot of folks will do that, but that's not true. You can't do that because it is a quadratic, all right? You can only apply the natural log rule is if you have a linear, okay? So what we're going to do is for this integral, and I'm not going to worry about this one nor this one yet, is I'm going to write this as x to the -2 dx. And now I'm going to integrate all three of the terms. One possible solution for this is going to be -1/2 natural log absolute x plus x to the -1 over -1, just by integrating this term, and then finally plus 1/2 natural log x plus 2 plus c from integrating this last term. Right? certainly we want to simplify this if at all possible. And this one actually simplifies pretty nicely. Another possible solution is we could write this as the opposite of ln absolute square root x, because we have the 1/2 power, minus 1 over x, if we were to simplify that second term, and then finally plus natural log square root x plus 2 plus c. And then finally, we have these two ln's. All right. Another possible answer we could get from this would be the natural log of the absolute value. This one's negative, so it goes in the denominator. This one's positive, so it goes in the numerator. Right here, it's positive. So we have x plus 2. All right. Minus 1 over x plus c. And then if you really wanted to, you could simplify it even further. You could say natural log absolute square root of x plus 2 over x minus 1 over x plus c. I guess if you really, really wanted to, you could write it as natural log absolute square root of 1 plus 2 over x minus 1 over x plus c. All right. All of these answers are the same. All right. Just a little bit different as respect to simplify. Okay. All right. So in another video, we'll go ahead and take a look at more of these sorts of rational sorts of decompositions and solving that way.